Before we attack, kill, destroy actual algebra, what we want to do is spend some time on some basic vocabulary and basic skills. So we already spent some time evaluating and simplifying. Now what we're going to do is look at opposites and reciprocals. So understand and use opposite and reciprocal. We're going to do a couple other vocabulario también. But first off, let's do some definitions. Turn to your neighbor real quick. Define any of these however you remember, but don't write anything down yet. Go. So opposite's a little bit hard to describe, but if you were to, you would say something like the positive becomes negative, the negative becomes positive. Okay? Mathematically or graphically, whatever we're doing, all we're doing is going on the other side of zero. The opposite officially is, on a number line, it's the same distance, other side of zero. So, other side of zero. So in contradistinction, absolute value is not the other side of zero always, but it's simply the distance from zero. In other words, positive stays positive and negative becomes positive. So we positivize everything. Reciprocal is, practically speaking, if you have a fraction, you flip it, right? To become 3 halves. So that's what reciprocal, practically, that's how you find it. But the definition of reciprocal is this, where A times the reciprocal is 1. It's the number that when you multiply, you get 1. Opposite is the number that you add to get 0. And now the next thing we want to consider is the word counterexample. For those of you who enjoy word dissection, we see 2 words in there, the word counter and the word example. So counterexample, counter means to go against, like to counterattack. Someone attacks, you counterattack. So an example that disproves a statement. For example, if I say, all cats have tails, all you have to do is point to one cat over there that doesn't have a tail. And you say, nope, that's not true. This cat over here doesn't. So, a counterexample.
Would Erica LaValle?
So, we're going to simplify the following. First, we're going to do absolute value. Then, as you see here, we're going to do opposite. Okay, absolute value. Absolute value is very straightforward. All we do is make everything positive. So, A, the absolute value of 18 is simply 18, because that's the distance 18 is from 0. 0. Next, negative 22. The absolute value of that is positive 22, because that is its distance from 0. And the same thing goes over here, not very difficult, 2/3, and this one is 0.52, so not overly complicated. Now, what about opposites? Well, opposites are slightly different. Opposite says this: if you have a positive, then it becomes a negative. However, if you have a negative, then it becomes a positive. So what we're doing is going on the other side of 0. Because officially, as we've decided or shown, is that opposites always add to 0. So for example, the opposite of 12. The opposite of 12 is negative 12. And the reason for that is because when you add those together, you get 0. Now, you don't have to write that part. The answer is just negative 12. But you can always think about it in your mind, why it is. All right, the opposite of negative 23 is positive 23, and this is where it gets a little bit more complicated. Officially, this one, it might be tempting just to write this and say, oh, it's negative x plus 3. And that's right-ish. I bet what people are thinking really is it's the opposite of x plus 3. So if you write it like this, you're absolutely correct, but it has to have parentheses. However, you could also consider it like this. You take the opposite of each component. So here you get negative x minus 3. And notice that essentially what we're doing here is the distributive property of the negative. So either answer is sufficient for the opposite there. So this one here, when I take the opposite, quickly, I'm just going to take the opposite of each term. So instead of saying negative 2a, I'm going to say positive 2a. And instead of saying minus 7, I say plus 7. All right, now down below here, it's asking us to compare and contrast. So we're going to use a method called double bubble to compare absolute value and opposites. So here's what double bubble looks like. I'm going to take my two categories. In one category is absolute value, and the other one is going to be opposite. And essentially, I make it into a bubble or, a square, whatever you want to draw around it, and the other one here, opposite. So these are my two categories right here. Then what we do is the things that they share, we're going to write inside. So for example, these are under the category of numbers. We take the opposite of a number, we take the opposite or the absolute value of a number, etc. And when I say numbers, technically you can also have variables. So, because a variable represents a number. Okay, what else do they share? Well, it turns out mechanically they share this, that whenever I have a negative, then it will become positive. There we go. But what is different about the two? Well, for absolute value, over here, if you have a positive, it actually remains positive with no change. But over here with opposites, if you have a positive, it changes to a negative. Now, there could be some other things if you wanted to get minute, you say they're spelled differently, but that's actually not so much the helpful part. Now, let's take this double bubble and convert the concepts here into a sentence or two. Both absolute value and opposites are operations to a number. For either one, if you have a negative number, then you make it positive. However, for opposite, if you have a positive, it becomes negative. And for absolute value, the positive stays positive. So as we look at the next page here, reciprocal. Reciprocal generally means whatever the fraction is, flip it. So this one's a very straightforward one. All we're going to do is keep the sign and make it 3/2. So that's the reciprocal. The reciprocal of negative 2/3 is negative 3/2. However, 20, it's not as straightforward. But if you remember that 20 is actually 20 over 1, now we can take that and wachatuya, flip it. Let's look at 1.4 and how to take the reciprocal of that. There's a couple ways to do it, but here's one of them. If I take 1.4 and then write it over 1, and then instead of 1, if I convert that to a 10 and move the decimal over there, what do I get? I get 14 over 10. Now when I flip that, I get 10 over 14. Simplify that, 5/7. So there we go. The other way of doing the 1.4 and converting that or finding the reciprocal is if I converted it to 1 4/10 and then did the method I'm going to do here on D. So to review, this is called a mixed number because we have a whole number right here and a fraction there. But if I convert this to an improper fraction, I multiply those to get 10 and I add that to get 11. So I get 11 over 5. Now, flip, flip, flip. So 5/11 is my answer. So the reciprocal of 2 1/5 is 5/11. The last topic we're going to cover is called counterexample. We've already defined that. Again, it is a single statement or an example that disproves a given statement. So if I say all birds can fly, I shouldn't say no, some birds don't fly. All I have to say is penguins do not fly.
Australian kiwi.
All right. Besides penguins, what's another example? Ostrich would work. We already looked at this one. All numbers are even, and you don't have to say no, some are odd. I could simply say this, 1.5. That disproves it. Counterexample, because 1.5 is neither even nor odd, but it's certainly not even. All positive integers are divisible by 2 or 3. And you could say, nope, 5 is a counterexample. 5 is divisible by neither one. I could have said 7. I could have said 10. Why could I say 10? Because 10 is divisible by, it says or, so 10 would not work. Because of the or. I was reading and it doesn't. All right. What happens if we mixed it up and actually did two things at once? What do we do? Have a quick conversation. How do I take the opposite reciprocal of a number? Negative. So the opposite reciprocal of this is negative 3/2. Negative 3/2. We're going to find out that the opposite reciprocal plays a very important role in linear equations and linear functions, specifically in perpendicular lines. So later when we look at lines and we're graphing this, and I want to find what's the perpendicular, that means it makes a right angle. Turns out these slopes have a relationship called opposite reciprocal.